Good morning. This is Engineer Suraj Singh speaking from Bharat, India to all world. This talk is about engineering and Excel file or worksheet. You can say, last time I tried to give information, but my file of more than 2 hours was cut into 1 hour, so I missed information. So I'm trying to share it again with you, whatever I missed in that file. This is normally, you know, this file you can see on screen. This is Excel file and regarding engineering theory of structure, regarding frame analysis. As you can see, soft solution, theory of structures, analysis of frames, moments and loads. Purpose is to share with you how how we can how we can use Excel sheet in engineering, particularly if you don't use software or if you want to customize our own work. That is the sole purpose of this, and purpose is very important. In last one I had given how the sheet works, and on this Kani's theorem I had given how these three cycles works. Means one cycle, second cycle, third cycle, first cycle, second cycle, third cycle, up to that, like this: first, second, third, first, second, third, first, second, third, and like that, first, second, third, and first, second, third, and first, second, third. And also supporting arrangement in this is supporting arrangement to browse the sheet is ranges F5. If you go, there are so many ranges in this. You can say first story analysis, first story CG table, then first story forces, first story method brief, first story notations, first story like this, first story analysis, this notations, quantities, first story RCFs, rotation contribution factors, first story result, first story sway, then second story 5S, and second story analysis, second story CG table, and second story forces, and second story method brief, second story notations, second story RCS quantity, second story RCF, second story results, second story, like that. All these four stories are there, 8 stories are there. Up to 8 stories, all notations are similar. And you can go to and see anyone. Let us say 8 story RC if I want to see. So I can see that. And if I see first story notations, you can say first story notations are this is notation here. And if say, okay, I go further and say first story method brief, this first story method brief, and if I say, okay, I say 5, and I go to whatever story you can go, 5 story results, so we have 5 story results. And if you say really first, I go to 6 story analysis, so this is analysis, but like that you can move wherever you want to move. It is just for information how ranges work. If ranges work, you can understand. You can use that. This takes little time to confirm range, but this is very important one. Now, okay, I'll go further here in this range. As let's say what we discussed before, I'll show you that one first. Is the first story analysis. First story. This is this is what we say like this. Let us second story analysis. Second story analysis, CG table forces. Let us say RCF. This is RCF here. Then we say after that, let us say first story forces. First story forces. I think also second story will go better. Second story forces. Second story forces. This is second story forces there. If I go further on this, let us say second story we talk of. So that we understand what we are talking. Second story analysis. We go to second story analysis. Okay, this is second story analysis. Okay, second story analysis. Okay, this analysis where cycles are shown here. And I'll go through sequence. I'm just telling you. And forces we are going to this analysis, second story notations, method brief. Let us say method brief. Okay, then we say notations. Let us say notations, and this is notations. And let's say then says let's go to RCA with the analysis view, the analysis, and this is analysis here, and then this is here. We go to the results. This is results here. These are results, and we go to let us say the story analysis. Let's go to verify the art results and two stories way, this two stories way, and we go to also results story versus quantities. The main important point is we have to show is CG table, that is CG table. So like this we can we can move and work on this. Now I have done this. I'll show you whole ranges. I will show you whole ranges. Let's say whole story. I'll show you first is the first story 5B. This is that is whole. You can see here. The story 5B whole picture is here of this. Now I'll show you. Let us say two story 5B. Two story 5. I'll show you it. Two story 5B. Same thing is here. Two story 5B, and you see here. And then it has a 3 story 5B, and you can say 3 story 5B. This is 3 story 5B. Whole picture is again here, and then you go to 4 story 5B. You'll see same thing here. 4 story 5B. This is 4 story 5B, and whole picture is here. You can say 4 story 5B, and then you go to 5 story 5B. This is 5 story 5B. 5 story 5B, and you'll find this. And then you'll say 5 story 5B, 6 story 5B, 6 story 5B, and that's here. And then it is 6 story 5B, okay. 7 story 5B is here, 7 story 5B, and 8 story 5B, 8 story 5B, 8 story 5B here. You can also go directly from here itself, if you wish to go. Example is 8th story, I say first story, and I say second. This is my own created links, and then 3 story, and then 4 story, and then 5 story, and then 6 story, then 7 story, 8 story. You can see that one, and then the control home is that one. Now actually links, I told you I will link it now in this additional links I would like to tell you this. I'll have this green color, free cells, all these are free cells. Now for example, generally we take equal sizes in all story heights in story floors. Say 350, this is beam, 350 this column, same way this, I have put free all these. You can keep them free or link. Somewhere I link, somewhere I did not link, but it's just for indication. For example, here I linked A10, you can see this is A10, and this is linked to that one because this dimension is same thing is here. You can keep above also. So this is second from top story. So here links I have shown here. It's up to you, not necessary, but if you wish, you there is a way you can do it. So if you make changes in first top one, you will make changes in bottom all if it's required automatically. It's not necessary that you, it's up to you. Means procedure is there, provision is there. If you wish, you can link like that. I'm telling you this one. Now there are so many issues in this. Means this is, for example, CZ area, this is, and this one is displacement factor area, and this one is rotation contribution factor area, like that. And this is load, how to apply loads in this. This is that one. This is one like this. So we have provided everything, and all green portion is free one. You can use that one. It's very important. A very important one. If you use one, okay. Now this is actually basics. This is actually very basics here. That is your analysis. In fact, this is a portion of range which gives you comprehensive answer for what you wanted to do. Means it's not simple as you think. It's very complicated, as you can see yourself. Each cell, wherever values are there, actually these are not values, these are calculated formula. There are values only in little. For example, there's 300. It's freeze this value. This same value is not there. It's length. This is all. This is all written here, like 4105 or something else, and we'll see how to. Otherwise, here you'll find all our linked values, and when you apply these three cycles, you'll find these results, and these results are further calculations. For example, in this is force, this plus this is force, this plus this is force, like that. These three cycles, I told you, there's a calculation formula, first, second, and third, and here also third, for example, then second, and one's involved, first are involved. Then these are, this portion and this portion, and this is a result of this based on this formula, and this is a result of this based on that formula, and this is a result of this based on this formula, and this is something else based on displacement factors. So these all are the displacement factors, and these are rotation contribution factors. So these are related to forces and analysis. So this one is something else. Value of means this U10, you can say whatever is U10, you can see what is that. U10 is here. This is displacement factor. So you can see line like this. Each when there's nothing that you in hand, and this portion deflection portion. Deflection is also formalized, very difficult but formalized. So this is calculation sheet for analysis. This is actually analysis of this, and very complicated analysis. Means in very small portion you have got all calculations, automatic calculations in this. For example, here written project PLM, point load moment here. This is projection plus W, window load plus etc. And like that, it's written everywhere. A simple moment, WL square 8, the WL square 12, 2 WL square or 12 is a FEM here, a fixed end moment, and this is a stress and steel possible, like that. It turns in horizontal, HR, horizontal sway, and you can see. So here are answers for everything, but the only professionals may identify it, but for your information. Now its results, because I cannot use this directly from this. It's very confusing, very complex. So what to do in real information? Example are these are results here. These are results. Whichever are results, it's coming here. This is our result. This is result, and this is written frame line, elevation, and results. Is very important from every viewpoint. And this is further calculations of center of gravity and quantities, etc. This is all that and also, as I said before, this will factor rotation contribution method, and its load area, what way we load, this seismic area, and this is various types of loads. Means span, name, etc. This file is from back. This file, we get this file, you get it. This is that file of loads. You can choose from this, or you can take your own. It is your one. No, there's no problem in that. So I'll put this file off. Why do we cumbersome with this file? and let me file off. Okay, now these loads are here, and this formula, the other ton parameter is load, which is coming for example here to here, it's coming from here to here. It can be changed there, means we can, depending on the controls, we can change anything in that. There's no way, each control is free. Similar here, two controls are free. For example, I make this 2, I'll change that one. It's changed in this portion. I make another one is also 2, it will change in this portion. So it's not a big deal. So we can say here, load generally comes on beams, and this load is width per meter, or the span. Span means length of beam column. This is, then you can say WL square over 8. This is for simple bending moment, simply supported bending moment. This formula, and this is value here. L square over 12. This is also formula of bending moment. L square over 24 is also formula of bending moment. L square 16 is also formula of bending moment. WL square 2 is also formula for bending moment, and this is also point load. So, and here is, this is moment calculations were there. Now this is also point load, A and B. A, where this load, the one end from support to that load is A, other one is B, and then is our FE, WAB square. So WAB square over L square. This is WA square B over L square, WAB over L. These are formula, and results are here. And this is seismic, where either can control here, it can be 1 or 0. If you make it 0, it should not apply, and if you undo it 1, it will apply. And this is horizontal force we have taken 25%. It can be different, and it can be 15%, for example, 2.5%, sorry, 15%. You can take it like this also, everything changes. So this difference here. Certain use 0 for gravity loads only, use +1 for seismic direction, use -1 for other seismic directions. This is here, this links to that calculation area. All these are linked, and all these RCFs are linked to calculation area. All this completely linked, and you can find that this link is here, all here. As I said, these are rotation contribution factor from that course. This is our moments, some of this, and this rotation contribution factor here from there. And loads, these loads which are coming here, these are from sheet, as this are, for example, here. Whatever is here is completely locked, and then deflection formula is here. You can see this formula, this one, and this one. So this is what this is enriched calculation table, very enriched, fundamental basics, and we have taken our way. There's nothing in this you can say. So we have this table, then we have result table, which are very important both. Result table is this is a result table, and this we have extracted only required information, not unnecessary calculations. Process we have left there, and this is sway. All these are same, various informations are here, deflection formula are here, and everything is here. And then further onto that, whatever we had to do, we did. So you can go to whole sheet. You see here there are 8 cases, so I have taken up 8 stories. You can take as many number of cases as you like. You can take single case or all cases, or depending on this. But this was done long back, and still it is working. So it is, you can say, just trying to show you. For example, it is very important. RSS R is rotational stiffness and total stiffness, TS, and distribution factor is DF. R is rotational factor, rotation contribution factor, W per load in tons per meter, T and bending moment in tons meters. L is span, FEM is fixed and moment, FM is fixed and moment, fixed moment, DL is direct load, WLM is wind load, distribution factor. Like this, everything is there. So means it's up to you. I am just browsing. I was moving along. Similar pattern is used for easy so that we can copy and expand if we wish to have one. Not to do everything again. I did using one, then expanded using same file but making certain changes. It's very complicated but not bad. Means it's very easy. If you do yourself, you look, it happens like that. But if you see this same, this is analysis, save analysis go, and this is brief methods is given. You can go there. This analysis, I'll go like that. I'm just going a little slow so that you can see also patiently. Seven story. This is 7 story and this is 8 story. I'll go this way to show you something else as well. No, it's still there, so I'll go to results. Yeah. You can see this results here. For every story, I'll go back, and this is seven, six, five, and then another one, and we'll reach there on top. It's another one. Various B1, and we can say the tables here, quantities, that's the same now. So what's actually, this way, whatever you think, it can be done. There's no problem in this, only it takes some time, your energy, your concentration, if you want to do that. It's not that very difficult, it's a good one. Purpose of this file is showing to you is that something can be achieved. It's not only this, there are many other files too. I'd like to show you many times. The last time I also showed to you because it's all missed. So I'd like to show you some files here. Let me go to my file. I'd like to show you certain other files as well. Yeah, in this also first let me show you what I did actually. Also edit links, these files are linked to other files that is in, I think, data edit links, These are links here. I showed you before also, when I show you. These are links here to this folder, this sheet. This links to the sheet. You see one file I've already shown you. Other one is here. RCC beams, limit state, 1 story 5B, Then RCC beams limit state to story 5B, RCC beams limit state 3 story 5B, RCC beams limit state 4 story 5B. These are the names of files. And RCC beams limit state 5 story 5B, 6 story 5B, 7 story 5B, 8 story 5B. RCC short columns limit state 1 is 1 story 5B, 2 story 5B, 3 story 5B, 4 story, like this. Is all R. And then working stress method. These are links. Purpose of this is that we can design them separately, but that's the only purpose. For example, we can design RCC beams, and if it is linked, automatically the files are linked. Only we have to see if we want to use this or we don't want to use this. It is not mandatory that use this. If you want to use this, you can go there and see. I'll show you an example here. Let's see. Let us see how it works, and let us see open source. Let us open source. The source is open. You can see that. This is beam values. You have to fill these values. You have to understand this. And the values, and you can put steel here, cover, and still all this you can do it in one go. And you can try, because without try nothing is possible. Okay. These details are here available. Also nothing is there. The M is modular ratio, MR is the movement of resistance, MR is movement of resistance, means movement resistance is MR. Then the neutral axis, and then gross depth, DT is tension cover, this is compression cover. Then beam width, and ASD is the steel, is tension compression. Characteristics, this is Phi, FC is compressive stress, E is modulus, and moment of inertia. And then other values are also here. Strain can be found from this. And this other file is also there, that is same file but with other connection. Then it's other sheet, then other sheet, then other sheet, other sheet, other sheet. Like this there are. There will be some problems somewhere. I don't know. Like that. And if we now I'll close this link and open another link. I'm not seeing anything, so we go into edit links, and let us say columns, open source, and this is open source of columns. So you can see now about columns, those are not complete. I am working still on this. I'll show that file as well if I remember where it is. I'm not sure where it is, but let me see if I can find that file as well. Or I'll show you from another one. Some file from Libya. Let me see where it is. Let me see to my drive first. I'm getting something here. I think I cannot find that file here. Let me see somewhere else. Okay, I will choose some of the files for that purpose. It's also very important that this is free of the file. It's regarding valuation. Mm. Guys, I think defense file is good file. I can see. Let's open this file and see what this says. I click this file. Now this is a different file, nothing to do with that type of design. This is a kind of you can say this is a project progress abstract, and a kind of file that can be used, a kind of formula that can be used for purpose of agreed valuation. Now when I say agreed valuation means not detailed valuation. Already some formula has been agreed in this case. In this case, it's abstract and details of each. What happens. In lump sum cases, in lump sum abstract cases, where work has already been done, and we never take measurements what was done. This is regarding lump sum contracts. I'm talking lump sum fixed price contract where we can say that we have complete details before the contract is done. Means when you prepare bidding documents, you provide complete details, and this bidding documents is so heavy that once you agree with that, that converts to contract itself. To contract itself. So there are various details. Whatever price we reach on that, whatever price we reach on that, need to say on that bid or job, that price is based on total requirements that have been included in contract specifications or designs or drawings or dimensions or unit rates, or you can say whatever is there. Means complete technical details based computations are included in that bid and also in that contract. So what happens? There may be any number of, there may be whatever number of components or buildings. There may be say 4 buildings, 5 buildings, or such structures. Every building has different bill of quantity to be prepared by designer or to be prepared by contractor. It doesn't make any difference. Both have every right to do this. But agreement is required because when work is done, you have to agree. How shall we evaluate work done? That depends upon quantity engineer from both ends, contractor as well as engineer. That is the most important point. Means once you agree, means you can say this building has 10 stories, so we agree on this building. This is price, and first story when it's completed, we will give so many percentage of evaluation, and when second story is done, on third story done. Like that agreement based on quantities. So a lot of work is done. You can say major portion of work is done prior to work start or when site opens. There's no very hard and fast rule. It depends on, means you have complete breakdown of quantities. Based on that breakdown, you have unit rates. You can approximately find what's cost of work done on this, and that's purpose. So it's not actually detailed quantity engineering for valuation purpose. It is indicative and based on only the worked out quantities. That's very important point in this. So now which page I am going to show you, I will not put any ranges in this. I'm just going to show, for example, this is project plus abstract, and this is, and this, there's this complete portion here. It's called interim valuation, they are saying. So this portion, if you see here, this is a kind of abstract file. This is abstract file. Components are shown, area gross per square meter, first phase development, whatever is there. Means this is costing, means how to create this. I'm not going to tell you how to create this sales values or references. It's a procedure, and we have to do it accordingly. For example, here it is 508. Formula is, everything is formalized, you can say. Everything is linked as that. So what where there is highlighted cells, you can say I put this as control cells, or you can say, values where you can add it. I mean to say, there's no bar to that. For example, in this 8 is there, 3 it is, there's no formula in this. Same thing, no formula here, no formula here, but this is formula. So this highlighted cells like this, wherever it is, you have to fill values in this, all cells you have to fill values, you have to edit, and wherever it is, only then it shall work. And you have to go through from beginning to end, check carefully and see values are done, and then you'll get your answers immediately. You enter each value, where the sheet goes on changing in linked cells, and that changes answer continuous, and until you keep on changing values, you get all answers. That's what is important in this point. So, well, I think you got what I'm saying. This is just for educational purpose. I'm telling you. I'm not saying I'm going to use this. All is usable, and this file is there. This depends on you how you use it. It's not mandatory that uses whatever agreement you have between both parties. You can use it for purpose of valuation. So it's just, you have to note how much work is done on each level and find quantities of that. That's the sole purpose of this. I'll go to some other way. It could be, I can say Excel file, then standard deviation of concrete. Let's see this one. It's also very important one. Now, though it's given, it's a formula is in Excel, but that is something else. Means when we are doing engineering, you have to think a lot of this. This is complying requirements of IS code 456, provisions 9 to 4. Enter cube compression strength results in highlighted cells, and there are two optional ways I done. What I did actually in this, complying requirements of IS code, whatever it is, concrete cubes is a soft solution for standard deviation determination using 30 samples. Just feed 30 values, obtained results. Obtained results, this is that, in this case, there are 30 values I added. Sample number 1 to 30, cube strength actual, average strength cube strength, average strength cube strength square, according to formula. We are doing this, whatever is formula. Now these values are free, means these are highlighted cells are free, and these are number of sample. So here average formula we apply B4, this is B4 and E4, AE4. So these are the average. Now what is standard deviation says? This formula for this that is here, B square over A minus 1, close bracket close, and power 0.5. That is formula. What to do with that? Average strength. This is strength we got from, for example, AF4 minus B4. What is B4 and what is AF4? That we have to see. AF4 is here. Average strength is here. AF4. Average strength. This is average, and then we say here cube strength. Actually, average strength cube minus cube strength. Average strength cube strength here. So the average strength, this is AF4, that's there, minus cube strength, this cube strength, V4. So we got this value like this. We have plus minus values here, and average strength cube strength square. Average strength minus cube strength square, square strength, cube strength, square. So this is B5 square then like this, and then we get, here average strength is this. So this 166 AF6 AF6 over A3 minus 1, this formula. So this is formula here, we use this. Also we have another way too. Samples are here, strength is there, same as that one. And now this is plus minus values are there as it was before. Now it is cube strength minus average strength. Here it is reverse, means their average strength must be, I am taking cube strength minus average strength. There are different values coming in, and then formula as it goes there. So this is also a way to work out standard deviation. And now we'll say something else here. This is something else. I'm not going to do this. Okay, we'll go somewhere else and see if we can do it. Now, purpose was just to explain to you. It is not very, different one. It's just to explain to you what I could understand now. Take in this case. I saw also here that I'll show you the same thing in the form. For example, I'll show you something. We expanded this one, 15 story 5 bay to 20 story 5, let's say. I'll put this. This is another sheet. Another sheet. It's different one. Another case that I expanded this from 8 to 20, 15 to 20. There are different files. So this is 15 to 20. This because solution key clause, and this is now. Now in this of solution graph structure, I have taken it 15, 16, 17, 18, 19, and 20. Let's go to 20 first of all. Let's say, okay, there's some problem. So we'll go through range. If I arrange there, let me see. I'm not sure. So let's go to 20 story. 20 story is here, and we go there. 20 story. This is 20 story. Means in this case, this is 20 story. Let me show you. I'll show you this first. And you can see that. This is 20 story, and I'll go to. I'll just show you. Means this is 5 base. So let me just squeeze it down so that you can see it in a better way. You can see this. A little more. So this is your. It is 20, story 20, so we can say, we can go to story 19 here. 20 story, then we can go to 19 story. This is 19 story analysis, and this analysis. You can count if you wish. This is here. like that, others. So yes, now I'll move like this, so that it's not necessary to go through range. You can go directly as well. This will take some time, but you can see that procedure is same, and only applications are different. I'll take here like this. You can see there also, see it happens, and then it happens again like this. If you don't want to go to range, or you can go to range, you go to range. Range is available, so I'll say, let us say this is 16 story. 16 story here, this is 16 story. And if you go to whatever story you can go, there's no bar. You can go. You go to 15th story, let's go to 15th story. You go in beginning, so this is 15th story. So I think you got my point. Means linking, of course, it takes time, but it can do wonders once it is done successfully. If you done comfortably, it is done, and you can see the results and these other CG values and these are quantities. And here is RCFs. These RCFs. Well, I think it's now understood that how can we work in this Excel. This is of course very advanced formula indeed. It's not, because everybody cannot do it, because it requires a lot of concentration, but one time it's done, then it can be expanded, and it can be used in different way. Edit, arrange, link, and you can link on same worksheet, you can link on other worksheet, you can link on various worksheets, and you can link on workbooks and workbooks to workbooks. Depends, provided it depends, and successful, provided you concentrate and understand, what's required and how it's required. That's a very important point here. It's not simply that you can take easy formula, you can take difficult formula, you can take whatever you want to take. It's all done. Formula is yours, it's not Excel's. It's your formula. How you want to operate, it's up to you. It's very, very easy. If you do it, means it's not very difficult. If you understand it, and if you know how to operate it, how to use it, only one time you have to do it, and next time controls can be used to change every value. That's very important point. Same time you can say can be changed in different value. That point is very important. And again I say that this worksheet is no limit to this. It can be used whatever way you want. Means it can be used in your way. This worksheet is just a road, but you have to drive your transport, your car on this. That is beauty of worksheet or Lotus or MS Excel, Lotus 1, 2, 3 or MS Excel. You are your master, you are your own judge. You have to move yourself. You have to talk to worksheet, you have to talk to cells, and you have to talk yourself. You can interact with Worksheet yourself when you drive on these cells. This road is full of cells and there are hundreds and thousands of tracks. You can go to whichever track you wish. And particularly in engineering world, this is considered a powerful tool in every subject. Every subject I say. It's not every subject, but you can say complete engineering. Somewhere formulas are not this intensive, but everywhere they are. Somewhere formulas are very intensive. For example, in this Carney's rotation contribution method of analysis of structures. And same thing is used by software when they integrated their software. And they use in background softwares, worksheets. And of course, in combination with drawing, you can connect it to structures and you can also use 3D in this case as well if you know how to use it. I think I will talk of that later because first we have to understand. Then you can do quantity surveying work, you can do bar bending scheduling, you can do this pattern analysis of structures, and you can do designs of beams and columns and slabs, and you can do whatever you wish to do provided you know how to use formula. Formula is very important part of engineering work. Everything is based on formula, and it's not easy. It's very. Also, I can show you something else. I like to show you that because that's very interesting. Let me do some demonstration of this. How is that? I'm opening one more file, Excel file. Let's say we say I want to say ax square. Let us say write an equation ax square plus bx plus c. Let's say just we call this 0. This is generally done. Now how to do that? Let's make a table here. Let's say its value of, let's first say value of x, let's say value of x column here. Let me say, sorry, this is x, okay. I'll take center one because it is much easier to understand. So this value of x, here is value of a, here is value of b, here is value of c. Let's say like this. We are keeping only one variable here, x. I will do later on. Now let's say I take whatever value. I write 1, then I write 2, then I write 3, then I write 4. Just to fill in, means something has to give. In this, let me just blow it up, like this. X, A, B, C, and there's nothing else in there. Now, what is the formula is ax square plus bx plus c. This is formula. So what we do, we can say here, let's say power is here. We can say power is here. This is 2 because we are doing a square. Okay, now we'll put here ax plus b here. Now how to do that? That is a very important point. Either because they are learning, so I'm just giving here. We say ax square. Ax square here. I say ax square here. Ax square. Ax square. Alright. This is ax square. This is all we have otherwise. Now what we do? We say x square then bx. Let's say this is bx, and let's say then cx and c, right? We just doing it again. Let us see how to know how to do ax square. As I said before, plus this is a, all right, and this is x, this is x, and this is power of power of x is 2. Where? So we get ax square. Right? What we get? X square. Means a is here, that is d6 into c6 is x to power g6, that is 2. Now we have one calculation here, and this is bx. This is b and this is x. This is x. Bx, now we get value of it, and c is always there, so we keep it c here. Now we try to found this formula. Now this is a kind of a formula, you can say here. This is a formalized one. This is a formalized one, and this is non-formalized, unformalized. So you can say this is formula for up to this portion is formula is this is not formalized. This is opens. You can say this is open area, open cells, and these are formula cells. Formula cells. So we have to understand open. You can do here. You can just highlight for reference, as I said. We got these open cells, and now let us do what we do. We say power. We don't know. Let us say sum of this is here. Let us sum it up, and how is this? Let us know. Sum it as per. Because we got this value, so we sum it and at rate sum a bx power. So at rate this power is also, I'm sorry, I did a mistake here. Let me do it. I'll actually, there's an error here. This is power is also this power is also here it is. So we take it separate so that it is identified. Now let us move. Ax square plus bx plus c. Let us sum here. At rate at sum. This is sum here. This sum here. That's that. 9 is coming now. So we have done, now it is coming. Even there's no calculation till now. It just randomly we wrote values, and we'll see how it works. While it says, we say there should be 0 here. Requirement was 0. So let's see how it works. Here it's coming 0 or not. Let us say true or false it will be. It's here because hold on. No, let's say x is let us say 2. This value is not, this can be 8. A is, let us say a is minus 2, for example, minus 2 I think now. So this value has gone down to b. I take 2, let us say. So obviously value is 0. You know that value is 0. Or we can take now another power, for example, rather than 2 we take 3. This value has changed now. So we can say, let us say 3, let's say minus 4. It's gone different way. And let's say minus 3. It's gone different way. Let us say BB2 1.5. Let's say A is minus, let's say 3. It's increasing and not coming to 1. No problem. No problem. What's the problem? You keep on trying. X can be 1. X can be 1.5. So let's say S can then 3 can be 2. You have to see this coming down or up. It can be 1.5. So it can be 1.75. 1.5 can be 1, 1.2. You have to see minus can be minus 2. Power can be 2.5. Like this means you have to try yourself. You keep trying. And this is x square plus bx plus c. And it can be whatever power. Let us say, in another case, we will say this power is enhanced, and I take it as that this power is a square. Now I take x over 3. Sorry, not here. Another one. Let's take here 3. Value changes. Let's take 2 value changes. This let's take 1.25 value changes. Let's take B. B is we can say, let's say -2 value changes. C is -3 value changes. So you are getting different value. Yeah, then it can be 1.1. Let's say value changes. Let's say -2 is -2.5. Value changes. -3 is -2.5. Value changes. Like this, you have to see. And there's no restriction in any power. I'm sorry. This is power 3. Then it should be then 3 here, of course. Or I say power 2.5, power 3, and it should be x power 3. So this is x power. Here also will change. So this is 3, I say. So x3 equation is, let's see, equation is here. Let's say x2 copy x3. So this is cube. So x3 plus bx plus c. So x3 plus c. So here is 3 now. Its power x 9.3. Let us say the 11 I have taken a x square x cube. A is here the 11, and x cube, x is there, x is the 11, and then it is cube. This is 3. This is cube. So that's value. To make trial and do it. Now it should be power now 1.15. Let us say this is 1.25. 1.1. That is 1.1, and it can be -2.2. So it's increasing. We can say -2.5 is down, -2.6. So it is down, further down. Here you can say -1, -2, -2. So this increase. So we have to go back and see. It can be -2.7. It's down. That is a -2.8. It is down. So it is changing. Yes. You have to bring it down. You can say C is also -1.5. It's up. So no, it should be like that. You can change, and you can do whatever you wish. You can do. You can take ax cube plus bx square plus cx like that. You can expand that as well. That expansion is very important. It depends. Let's try this. Expand further. Now ax square, x cube plus bx square. Let's see that first of all. Let's do like this. Let's like this now. So we'll say ax cube plus bx square plus cx you can say cx plus d. So we have expanded this further. We're going to change this now, and that's important. My people are just looking for nothing. This nonsense people, I don't know what to do with them. So we do like this, and it's really, we do like this. You can say here we can say that x is there, a and b are there, then x is there, b and x is there, c is there, x is there, d we have to add, a we have here, x we have here, b we have x, a is there, b is there, c is there, d is not there. So what we do, we just cut it and put it here, so that this is, we put B here, D here, D here in this case, and then we'll make it differently, and we change this format, so this is B here, and we make this again format, and this format is different now. So this is D here, and value of D can be, so we can just have same thing here. We can say that, format method, format here. Now we have to see here ax cube plus, we have to see here x cube plus bx plus c, ax cube plus bx plus c plus d. So we there cut it out and put here, d. This is d here. Let us say for ease working, d here, and this is d plus. So we can say whatever values there, we'll see. I just keeping 0 now, no problem. We can change it, and we can like this. This is now, this is here. So we, whatever value of v write is, example I write value of v is 2, 1. It's here 1. Sum is also here. We have to see I, let us say sum I16. Let us check it, it's okay or not. So it's not okay. We have to pick from here to here. It's there, 1 7. So this value is here now. A sum 16. So this we have to follow now. This is all same area. You can say open cell, formula cells. You can say open cells and formula cells. You can say open cells and formula cells. It's here. Okay. Then what you say? Now what you do? You have now. If I say 1.5 here, we can change this value. 1.5 here. Oh, sorry, 5. By mistake it is 1.5. Let me say 1.5. I say it's come like this. It's 1.1. I say okay, that is 1.02. Then I say 2.8 minus it. Let's say 2.5. Is 2.5. Let's say minus 2.2. And then D is, let us say 1.75. So you see, like this, you can trial 2 or 3 trials shall help you. This is power 3, and we have bx square is also, I'm sorry, bx square we have to take this power, I forget, then cx also the other. So bx square means bx square, bx square, x square is here, bx square, and cx here, cx, so we take cx here, right? And d, so bx square is d is there. This is E16 is b, x is square, b, x square, and this is C16. So we'll take a square of this here. Here like this. Hold on, something wrong maybe. Bx square. E16 is b, E16 is b, and x square, and x is C16. So we'll put here something. Why is not taking? The point is that cx square. I will take power x square is, I missed something. Hold on. This is what we have to understand. X cube we have taken, bx square, x is there, bx square, power 2 we have taken here, that is power 2 we have taken h, so we have to take power 2 also here. That's what we missed actually. We have to take power 2 and put like this here, power 2. We could take x, now this is power 2 here, this is power 2, and I will put first of all like this, so that it's better to be clear. We get border now, and here we say power, and power is 2 here, power 2. So this is power 2, means whatever information we need, It should be clear to us. That's the important point. If it's not clear to us, we make mistakes. So this is now full power. Now power 2, so we say bx square, bx is b is here, e is 16, and then we say x square, that value is here, bx square. It is c16 is x, so this is square now. So we got this value here. So now this cx, we have to see cx as well. F16 is there. F16 is now, yeah, c and x is 16, c16. So we will say multiplied by c16. This value is there. So we got this value. Now d is there, which is same as g. So d is already formalized. Now we take this from here, from sum up, we can say this 16 and this 16. So this value. So this is formula cells of which is just shift formula cells from here to here. This is formula cell actually. We'll remove this. So our formula cells is there. Remove this as well. Formula cells. Either remove this or remove this. One or two. It's not going away. Why? Why is not going away? Alright, no problem. So something wrong here, I'll put this here, I'll delete this here. So delete there, put there a formula and put there. So we have open cells and formula cells. You can make whatever number of trials. You can take here, let us say 2 and put it like this. So it will go down. You say 2.1. It goes further down. If you say 1.95, it goes further down. And if you say 1.9, 1.2 only, 1.95. So let us say to 1.1, let's say 2.05, 25. So it's like that. You can make whatever changes you wish to make. You have to, or you can make changes here, minus 2.25, like this, or minus 2.15, minus 2.15, minus 2.15. We'll make here. That's minus. This is minus. Let's say minus. Yeah. 0.5 is a minus 2.05. So it's already minus 2.023. See, it's reaching here, minus 2.02. So it's almost reached minus 2.01. So we can say minus. Sorry, just press down. Something happened here. Like this, you can say 2.01. You can say minus 2.01. You can say it's going reduced, and that's the way that you can formalize this. This is only for demonstration purpose. This is only for demonstration purpose. You can say something else. For example, now I'll give some examples which are good for you. Means let us name this demonstration formula. Let us name this also. Let us say name this book the demonstration formula. That's a formula demonstration. Formula demonstration. for the demonstration I will take it somewhere here. On which file we take, let us say in D, and in D we'll take in open, let's say, alright, we take it. No, we can take something else also. This is some other formula. What formula like we should take? Let us say we have some formula. What I should say? Let's say WL square over 8. WL square over this one, some formula. WL square over 8. WL square over 8. It's a kind of, some formula that is bending moment, we call it bending moment. I'll write this for your better. Bending moment simply supported beam. Well, so this is now W. Let us say in one part we take W, then we take in other part L, and we take in other part 8. It's so simple. We take three variables here. No, 8 is not variable. L and W are variable, because now we'll take here whatever value of W is, I don't know. Let's take 5. And let's take 8. And 8 is of course 8. We cannot change it. So in this case, here these are, editable. You can say you can edit them. And here formula we have. This is our input value. You can say, hold on. This is our input value. This is our input value. I'll just give border to this for verification. Now WL8, we have the values and we have to formalize this. There's no other square or something in this except L square. So we can take, rather than taking L here, for our convenience, not necessary, but we can say we'll take L here, and square here. Okay, L square, we take this L square. How to do it then? Now plus L is there, and square is there. Square is find this. So we have L square already. So this will automatically change. We cannot change anything. This is now okay. Now formula we have to keep. W we have, L we have, and 8 we have. We'll say WL square formula. Let's say W square here. This is WL square here. I'll directly put it here. Don't need going around. We'll take W. What is W? This is W into L. What's L? This is L, and this is square. We don't take this. It's simply because we have W is W, and L square we have, L square 8 we have. So why to go long? We have this one. So this is L square, and over 8 is here. So is that not answer? This is an answer. It means it's up to you how you do it. You can see this W, C20 is W, and L square over 8. L square over 8 is F20, and we divided by 8 that is there in 20 is E20. So this is our answer, and this is our answer here, and this is our answer, and this is our input. Input values are these. These values are input values, you can say, and this is the answer. So this is very simple formula, and whatever you can take, you can take. There's no restriction on anything. It's your mind how it takes. Your trial, your design. It's not somebody else. It's you have to say how can you do it. So we have done some formula here. Let us see what now we have something like that. 5W. Yes, I'll just give you something. I'll say this is a formula of 5W L YL, I think we have, let us say WL square over 24. Okay, we'll do something else. WL square over 24. Let us say here WL square over 24. And this is also Benjamin formula. This is Benjamin formula, so keep it here. Copying here, both and this also Benjamin formula. It's not simply supported, but some others. So it's not simply supported. Okay. WL square over 8. So WL8 we have. This is 24. I'm sorry, this is 24. 24. Let's say. So let's bring whole as copy here first. Because already we have it. By the work again. So WL8 here we get 24. So that is 24. And because we didn't put linkage, so we have to just link it here. Better we can do by linking also. We have to change this. Or if you change it, don't link it. If you change it, don't link. Leave it as this now. And now what we see, WL square 24. Now L square it was, we say L square as it is, and we'll say here WL square 24. This is formula here. WC24 is already there, and L square, let's say here L square, so we'll give it WL square, WL, C24 is W, L square F24, F24 S square is here, or 8, in place of 8 here, we will put the 24 here, because we are on 24 now. So I'll put the 24 here, and put 24 here. Okay, so that is for indication of formula. So this value has come, this one. You can see this value has come, this one. All these are values. This is value here, and this was value there. Similarly, it can be used for whatever other formulas. There are so many formulas. In all calculations, and isn't that easy as we think so? It's everywhere like that. So, well, I think I wanted to give you something about how best we can use worksheet, or you may call it a spreadsheet, or you may call it whatever. It's not that difficult as some people think, because whatever, it's very advanced. We have taken so many formula, and this demonstrated you last time also in many, for example, solar system, and for example earth volume, etc. And that's a very big calculations, very big, and the solar system itself is a very big one. But we did that. That's a very important point. We did that successfully. So what I mean to say that do not run away from calculations, even if you are not intelligent, or you're not secured in mathematics or mensuration. Okay, scientific, I was forgot. I demonstrated to you like valuation today, like standard deviation, and like I showed to you many files and their connections and linking system. It's really very important one if you take it from practical viewpoint. Really, it's you may say it's miraculous, though it's not miraculous. It's very, very common that we have to be careful about this point. My purpose was to show you all this and all that, as we showed before as well. It's really, interesting that we are able to understand this one, and you can do whatever you wish. It's up to you, as I showed to you, beams and columns also. How to manage? It's not my mind that will tell you. This worksheet that will tell you. It's your own comfort of working, or how to simplify. Maybe first time you may not do that, but you can do whatever time. Like this, I use this 5, I use W5 here. I can use it 4 also, there's no problem. This L, which I take an 8, I can take 5 also, no problem. It will change everything. This W I can take 2 also, it's no problem. Where a formula can be added, it can be added. L5 I can say, okay, I take L6, no problem. It's the same way here, you can change anything. That's why Excel teaches us how to change, how to consider variables. Variables means which can be varied, and how to understand fixed values. So it depends on like that. If you people understand that point, well, I think it works. And if you don't understand that point, it won't work. It's linking of cells, number 1, and it is linking on cells and hyperlinks as well to other workbooks or other hyperlinks somewhere else. Number 2, then it is putting in formula in cells number 3, and linking to same workbook sheet, and then linking to other workbooks. And editing links means you have to link automatically. You'll find links within edit line, edit list, and from there you can find files if you are in a hurry, or if you want to save time, and also if you have some time, and you can constitute ranges. You can constitute ranges of your worksheet. Your worksheet may be very big. Maybe you are using all rows and columns, so there will be hundreds of you can say ranges you have to make. One time you have to do it, which doesn't cost much except time and concentration. And if you are able to do that, you can second time, third time save a lot of time, because you formalize that. And formalization means intellectualism, concentration, your vision expansion. Depends on, though it may not be understood by those who have neither calculation knowledge nor Excel knowledge, or even they have Excel knowledge, they don't have calculation knowledge. This means there's a drawback. Well, I think I have given you some calculation background of Excel. It's not you can see I'm becoming. Now let us say, for example, let us say here I want to make something out of here. The question is that may not be supported by this valuation. So I thought I discussed with you about simple countings and tabulation also. And also yes, very important point that I like to give you is that suppose I want here say it is some values here, let us say some values there 5 for example, and this is here just I want to make many powers of this. So let's say this is here, and I want to put power of 2 here, power of 2, power of 2, and you see this is answer, right? This is answer. Let's demonstrate something that you should understand. Let's say this is very simple, 2 cells I'm using only, but very complicated. Now this is variable here, and this is not variable, this notifies. So now I want to give further power to this. Let us say this may be another 2 power. You see it's gone up. You got it? Let's say I want to give it to another power. Let us say I put in bracket first because sorry, parenthesis first, and so that the power, let us say this whole power here, I want to use this parenthesis here. Now say let us say power 3, hold this power 3. I'm compounding this actually, this power 3. So you can see this comes in like this here. You can see the formula now, and I can say no, I'm not pleased with this. I want with another power of this, another power of this, and this another power is 2. So this is that. No, is multiplication 2. I want power of multiplication. So there's an error here. I want power. Let us say power. So you know power has come like this. You see E28, this value square, and it's a square, and now I'm saying another one. I want to raise it to another one, and it's another one to power. You know, this is to power 1.5. No multiplication. Why do you say multiplication? Nonsense. Why is not understanding this thing here? What nonsense, yeah? It's not. It's playing with me. What's the problem to you? Okay, this is the formula. Now I'll make a correction here. Maybe this computer is playing with me. Let us say it is here, and it's power. It's power 3. It's power 3. So one power, another power, another power, another power. Let's make another power. Let's make another power, another power. Let's make another power, and make it power again, and make it 2. Make it 2. So you can say it's there. So you see expansion of powers is going on. Let's take another one, and another one here, parenthesis, and let us take power here, and what is it, power SSA. Let's make power 5. Power 5. It's not accepting, means there's, let's make different power. Maybe its capacity is full in powers. So let us say 2 power, and 2 power. So 2 power is here. You can see it's accepting here. Now this is one part. I say this is, I'm not happy with. I'm using another one here. Let us say, okay, and I say I want to add to this, this value. Let us say whatever value is there. This value is there. I want to add this value to this one. I want to add this value and also this value, minus this value there. I want to add this plus and minus both to this one. This formula. Now I have to do what? You can say either I go here and plus make this, and plus make this. This has changed again. You can say this has changed. Simple. And I say still I'm not happy with this. I want to make square of this hole. I want to make square of hole, square of hole. So it's giving num, means it's not accepting. So means it depends how much power it can take. So means it's very old sheet I have, maybe it's some limitations, but you can see formula is increasing and increasing and increasing. And if I say, okay, fine, I have this power, this power, this power, I will sum all these, so I can say iterate sum. I want to iterate, iterate sum. I want to sum up this from here to here. Is another answer. It is summed answer. So this is, sum of this. And then I say, okay, I want to come again sum of this. So you can say sum of this, again sum of this. I will do again sum of this here. This you can see, this is this one. So you see, you can use formula in your way. There's no, I can cut it, I can move it, whatever, you can move it here so that it looks symmetric. So it remains same, doesn't change, values move same. This change, and this change. So this is where it is about. I just try to give you some what I think can be done, and it's not that simple, but it's practically possible. Well, I'm not keeping off this. I'm keeping off this video. But next time I'll give you, because we'll talk of some other video. I'll come on solar system. So I close it. Thank